For a derivative to exist, the graph must be continuous at that point. And we're going to talk about continuity tomorrow. I'm going to write this in two ways. I'll give you a second to write that down. We'll talk about continuity tomorrow, but it has to be continuous in order for it to work.
What do you mean by continuous?
You'll ask me tomorrow. What continuous is, you can draw a graph without lifting your pencil. That's what continuous means. So a continuous graph would look like this. This is a continuous graph. This is a non-continuous graph. Okay, that's basically what we're talking about tomorrow. Okay. And just like remember how before we did like this thing. Remember we did this sort of thing? But this would be a non-continuous graph.
Yes.
Right? Because at 0, let's say slope is 0. Well, we don't know because there's three different weird values, right? So anyway, I'll leave that for right now. That's a glimpse into your future tomorrow. Okay, there's an equation for a derivative. One was created by Newton, the other was created by Leibniz. Here we go. We'll have to memorize this for your test. It will be very difficult. You ready? No, f prime. It's not inverse, just prime. F prime of x. Okay. You've never seen that before in your life, I'm sure. But that's what a derivative is. Okay. The other way you can call it, this is the other one here. They mean the same thing. If you're in calculus in university, some teachers like this one better. They both mean the same thing. dy by dx means a small change in y per small change in x at your slope, right? A small change in y compared to a small change of x is called your slope. So I should probably write down the board. F prime of x is the derivative of f of x. Dy by dx is a small change in y divided by a small change in x. And that's where the limit and all that stuff comes in there again too. That's all I got for definitions for today. The rest of the class is examples. Okay. Now again, you may notice that's the same equation we've been using all the way through it. Yes, that's true. Okay, right? That's sort of an important equation. It's the one thing you need to know for this unit is that equation. Well, because they're the same. There's a delta H. They're the same thing, right? They're the same thing. Either one works. The reason I bring them both up, I will mostly use this one. For some proofs in dy by dx works nicer. That notation works nicer. When you get to university, your prof may do delta x for everything. I don't want you to never seen it before, and you just say, forget it, I'll change to h, right? But if your prof uses this delta stuff, at least you've seen it before. That's what I'm saying. Michael, are you ready for example 1? Michael, it's up to you, right? I think it's up to you. Example 1. I'll open this to anybody here, and then we'll go back to Michael. Michael, take us through. Example 1 says, if f of x equals x squared, find f prime of x. Go. Can you please show off your great math skills right now? Go ahead.
X of x plus h in the equation. And x squared plus 2xh plus h squared minus x squared.
Yeah, I'm just going to do it like this, but you're exactly right. It turns into, each approach is 0, x squared plus 2xh plus h squared minus x squared all over h. Austin, what do I do now, please?
Cancel out your x squared.
Yeah. Okay. Now think the way these are always going to go. Hope you sort of start to see a pattern. Whatever this is going to be removed, right? Like whatever your f of x term is, and you've seen this a lot, that's pretty much got to go. All right, that's pretty much the pattern that's going to happen. All right, Liam, even though you're not in this class, what do we do now? I'm going to rewrite this, but then you're going to...
You could just like take a common factor.
Yeah, sounds good. H comes out, and we're left with 2x plus h. Okay. Graham, what's our final answer then? Just 2x. Let's, you guys are in grade calculus. Grade 12 over here, I guess, not calculus. Okay. Whatever. Okay, it's been a long night. My kids are sick at home. It's been a long night. Okay. Is this okay before I crank it up a little bit? Is this okay? I hope you've done lots of these the last 2 weeks. Yes? Here you go. Example 2. Bring it up to a 1 out of 10 difficulty. You want to start at 10?
Start at 10 and work our way up.
You want to work up to 1?
Start at 10.
Let's start with a nicer one first, and we'll move it up after this. If f of x equals... Okay. Now, on your test, there is a shortcut to this. At least one person in the class knows, named Leah. Okay, but for everyone else, if you discover a shortcut, I'm going to say on your test using first principles. First principles is the limit method. Okay, because I want you to practice your algebra in this first unit. Okay, because there is, I can do this in half a second, literally. Reed's going to hate me when he figures out the pattern. Reed's going to hate it. It's like that time, remember how you had to complete the square that I showed you?
Yeah.
Remember that? And you were like 3 attempts
That's
on it
pretty
wrong.
frustrating.
Anymore. Sorry, I hope I wasn't recording. That was recording. Sorry, Reed. Oh shoot, I should have stopped it. All right, let's do this anyway. Okay, I'm going to write the general equation here. Okay, Reed, sum some numbers for me, please. Go ahead.
-3 bracket x plus h bracket squared plus bracket x plus h bracket cubed minus bracket -3x squared plus x cubed bracket all over h.
Rolls right off. Doesn't that roll right off the tongue there? It's minus 3x squared plus x cubed all over h. Okay. Lovely. In fact, Dakota, see your foiling skills, please. Go ahead.
Oh boy. The root is different. Let's swing it. -3x squared.
Yeah.
Plus -6 xh.
Yeah.
Minus 3 squared.
Yeah.
Plus x cubed.
Yeah.
Plus 3x squared h.
Yeah.
Plus 3x h squared.
Yeah.
Plus h cubed.
Yeah. And then
3x squared.
Yeah.
Plus x cubed.
Minus x cubed. Yes. Okay, now, if you do not have your Pascal's or binomial theorem memorized, you can FOIL it out by hand. But you certainly can FOIL out x plus h cubed by hand. It's difficult and long. I will, if I won't, the way it's always going to work is that it's just going to be like x plus something cubed. If I do like 4x cubed, that's going to be 4 times, right? Right, so it's just going to go like that. You will not have more complicated coefficients other than x and a number that you don't even need to FOIL it. Sam, what do I cancel, please? I'm going to write that as It is awesome. Negative 6xh minus 3h squared plus 3x squared h plus 3x h squared plus h cubed all over h.
Yep, we're just gonna use.
What's that?
Get rid of some of these.
Yeah, we'll get to that in a second though. We're looking okay. So is this, did I make algebra mistake yet? Caitlin, this is accurate, relatively accurate so far? Matt Boucher, what happens now? One H leaves with everything, okay? So this is limit H approaches 0. Negative 6x, negative 3h, plus 3x squared, plus 3xh, plus h cubed. H squared, sorry. Are we feeling relatively okay about this? No comment means keep going. Robert, what do I do now, if anything?
You sub-zero with breach.
Very good. So what does this turn into then? There we go. Okay, anything with an H. So even though there's an X and an H here, that still crosses, right? Okay. I would like to hit stop on this machine. I'm going to put their heads on their desk right now.